Starting with the last term question then, it says, for a solution of lithium hydroxide and methanol, what is the solvent and what is the solute? Well, the solvent is the liquid that causes something to dissolve or that the substance dissolves in. Here, that's the methanol, so my solvent is methanol. A solute is the substance that is being dissolved, and in this case, that's lithium hydroxide because that's what's being dissolved in the methanol. So my solute is lithium hydroxide. Last month's question says, a student carries out a chromatography experiment on 4 inks. Explain a change to the experiment that would be needed to separate the dyes in ink sample Y. So if you look at the start line, you can see ink sample Y hasn't moved. The dots, the dyes in the ink have not been separated out. That's because Y is insoluble in this particular solvent, so the change you would need to make is to use a different solvent. Using more of the ink would not change how much is separated. So the only change you can make is using a different solvent. Last week's question says, what did Mendeleev put the elements in the periodic table in order of, and how is that different to our periodic table? Well, we know Mendeleev arranged elements by their atomic mass, whereas we arrange our elements by the atomic number, which is the number of protons. And if you forget that in the exam, you'll have your periodic table and the key in the top left corner to remind you. And you've then been asked to draw a dot and cross diagram for potassium chloride. Potassium, I know, has 19 electrons, 2 in the first shell, 8 in the second shell, 8 in the third shell, and 1 in the outer shell. But for the purpose of dot and cross diagrams, I only need to include that outer shell. I know it's going to lose 1 electron in order to have a full outer shell. So it'll form a +1 charge, and the shell I'm including is just that outer shell only. Chlorine, on the other hand, has got 7 electrons in the outer shell, shown by my 7 dots. It needs to gain 1 in order to have a full outer shell and become more stable. So I've got potassium trying to lose 1, chlorine trying to gain 1, so the chlorine will take an electron from the potassium, as shown by my cross, to become an ion with a -1 charge. And I've shown that outside of my square brackets. This lesson, we're going to be looking at ionic formulae and also chemical formulae and what they tell us about how many types of atom are present in a compound. And it'll also help us with balancing our equations, which we'll look at next topic. Pause the video and have a go at drawing a diagram for the following ions. Okay, so hopefully you've been able to identify that beryllium has got 4 electrons, 2 in the first shell, 2 in the second shell. In order to gain a full outer shell, it's going to lose 2 electrons and form a 2+ ion. Oxygen has 8 electrons, 2 in the first shell and 6 in the second shell. In order to gain a full outer shell, oxygen will gain 2 electrons, which I'm going to draw using dots, which means it will have a charge of -2 because it's gained 2 negative particles. Aluminium has 13 electrons, 2 in the first shell, 8 in the second shell and 3 in the outer shell. It will lose the 3 electrons to form an ion with a charge of +3. And finally, sulfur has 16 electrons, 2 in the first shell, 8 in the second shell, and 6 in the third shell. Like oxygen, sulfur is going to gain 2 electrons. That should be an S in the nucleus. So it's 2, 8, 6. It'll gain 2 from another atom, which is why we've drawn them using dots to form a -2 charge. And the ion, don't forget, is named sulfide because it's negative. So it's a sulfide ion. As another recap, pause the video and have a go at drawing dot and cross diagrams for the following ionic compounds. So this time you're going to have to do it for more than 1 atom per compound. Remember, you can just use the outer shells only. So moving on, we know calcium has got 20 electrons. The electron configuration is 2, 8, 8, 2. So calcium has 2 electrons in the outer shell. It's going to lose those 2 electrons in order to acquire a full outer shell. So therefore, calcium will form an ion with a +2 charge. However, we don't need to include all of the shells, so I'm just going to include the next full shell and my square brackets to denote the charge. Bromine, on the other hand, is going to have 7 electrons in the outer shell because it's in group 7. So each bromide ion wants to gain an electron from calcium in order to have a full outer shell and form a charge of -1. However, there's a problem. Calcium wants to lose 2 electrons, but bromine only wants to gain 1. That's why I need 2 lots of the bromide ion. I need both of them to accept an electron from calcium to make sure calcium has a full outer shell and the 2 bromide ions each have a full outer shell. Instead of drawing out the bromide ions twice, we can just put a big 2 in front so that we know that 2 lots of bromide ions each accept an electron from calcium to form an ion of -1, and calcium forms an ion of +2. Potassium oxide, on the other hand, so potassium has 19 electrons. It's got the electron configuration at 2881, so it's got 1 electron in the outer shell, which it will lose in order to acquire a full outer shell. Again, I'm only going to include the last shell because the inner shells don't take part in bonding, so the last shell I'm going to draw for potassium should be the nice full shell, which adds that extra stability. If it's lost 1 electron, then it'll form an ion with a charge of +1. Oxygen, on the other hand, is in group 6, so it has 6 electrons in the outer shell, so therefore oxygen needs to gain 2 electrons to have a full outer shell and form an ion of -2. Again, we've got a similar issue as above. Each potassium only wants to lose 1, but oxygen wants to gain 2 electrons. Therefore, I need 2 potassiums, both of them to lose an electron, so that oxygen can accept 2 electrons, 1 from that potassium and 1 from the other potassium, to give an overall charge of -2. In the last lesson, we looked at using the position of an element on the periodic table to predict the charge of the ion it will form. So we said everything in group 1 forms a +1 ion, everything in group 2 forms a +2 ion, everything in group 7 forms a -1 ion, and everything in group 6 forms a -2 ion. However, for the ions you can see in the yellow box, it is not possible to use their position on the periodic table to predict the charge of the ion. And the reason for that is each of these ions is made up of more than one element. We call them compound ions. We know the periodic table only contains elements, not compounds, so these compounds do not have their own position on the periodic table. So for that reason, it is not possible to predict the charge of these ions using the periodic table. That means it's really important that you learn the formula of each of these 5 ions as well as the charge, because in the exam you might be asked to write a balanced equation for the reaction between calcium carbonate and hydrochloric acid. If you don't know the formula for the carbonate ion, it means you'll struggle to build the formula of calcium carbonate and therefore balance the equation. So you must learn all 5 of the following compound ions. So starting with nitrate, we've got NO3, 1-, sulfate, SO4, 2-, carbonate, CO3, 2-, ammonium is NH4, 1+, and hydroxide is OH, 1-. If we focus on the nitrate, sulfate and carbonate, you can see from the naming they all have something in common, and that's that their names all end in 8. But if you also look at the formula of each of these compound ions, they also have something else in common. They've all got oxygen in them. So anytime that the name of the ion ends in 8, it means that it's combined with oxygen. So 8 means there is oxygen present in the compound ion. So nitrate is a nitrogen and an oxygen. Sulfate is sulfur and oxygen. And carbonate is carbon and oxygen. Our only exception from the last slide would be hydroxide, which is just OH minus. The chemical formulae tells us how many of each type of atom there are in a chemical substance. So for example, if I've got the chemical formula of water as H2O, that tells me there are 2 hydrogen atoms and 1 oxygen atom. If I look at carbon dioxide, CO2, I've got 1 carbon atom and 2 oxygen atoms. Calcium chloride, CaCl2, I've got 1 calcium atom and 2 chlorine atoms. Sodium oxide has 2 sodium atoms and 1 oxygen atom. Sodium nitrate has got 1 sodium atom because there's no number immediately following the sodium. We've got 1 nitrogen and we've got 3 oxygens because that 3 is directly behind oxygen, so it applies only to the oxygen. So there's 1 sodium, 1 nitrogen, but 3 oxygens. And the more difficult example tends to involve the use of brackets. So how you deal with brackets is as follows. So as I can see, I've only got 1 calcium atom because there is no number immediately following the calcium, so that means there's only 1 calcium. I've got nitrogen, but it's inside my brackets. So to deal with that, we just need to realise that everything inside the brackets is multiplied by the number outside the brackets. So inside the brackets, I've got 1 nitrogen atom. However, we need to multiply it by the 2 outside, so there are 2 nitrogen atoms in total. I've also got 3 oxygen atoms inside the brackets. However, outside the brackets, there's 2, so I've got to times that by 2, so that gives me 6 oxygens in total. Pause the slides and have a go at determining how many of each type of atom there are in the following molecules or compounds. Starting with magnesium chloride then, there is 1 magnesium atom and 2 chlorine atoms in magnesium chloride. For lithium oxide, there are 2 lithium atoms and 1 oxygen. For sodium fluoride, there's 1 sodium atom and 1 fluoride atom. In calcium sulfate, there's 1 calcium, 1 sulfur and 4 oxygens. Remembering that that little 4 only applies to the element it immediately follows, so it only applies to the O, not the S or the calcium. For lithium sulfate, I've got 2 lots of lithium, 1 lot of sulfur and 4 lots of oxygen. For magnesium nitrate, I've got 1 magnesium, 1 nitrogen inside the bracket, but we've got to times it by 2, so 2 nitrogens in total, and 3 oxygens inside the brackets, times by 2 gives us 6 oxygens in total. We've got ammonium sulfate, so I've got 1 nitrogen inside the brackets, times by the small 2, so there's 2 nitrogens. 4 hydrogens inside the brackets, times by 2, so there are 8 hydrogens in total. There's 1 sulfur and 4 oxygens. Don't forget, every time there's a new capital letter, that means there's a new element. So sulfur and oxygen are treated separately. There's 1 sulfur and 4 oxygens. A common exam mistake would be to have 1 lot of sulfate, but they are 2 separate elements. And last one, we've got aluminium sulfate. Well, we can clearly see there are 2 aluminium atoms. There's 1 sulfur inside the brackets. We've got to times it by 3, so there are 3 sulfurs in total. There are 4 oxygens inside the brackets, times by 3, so there are 12 oxygen atoms in total. So you need to be able to build chemical formulae like you've just determined on the previous slide. So in addition to being given the formula and determining how many types of atom there are, you need to be able to tell the examiner that you know sodium chloride is NaCl, whereas calcium chloride is CaCl2, and aluminium chloride would be AlCl3. So in the first example, we only need 1 chloride ion. In the second, we need 2, and in the third, we need 3. You need to be able to understand the chemistry behind that and build those formula for yourself in the exam. So let's start with an example. To find the formula of the overall compound, you just need to figure out the formula of the ions for sodium and chlorine. So for example, I know sodium is in group 1. So there is 1 electron in the outer shell. So sodium loses 1 electron to gain a full outer shell and forms an ion with a +1 charge. Chloride, on the other hand, is in group 7, forms a -1 ion. So I've got +1 for sodium and -1 for the chloride ion. The rule is that the overall charge in any compound, so sodium chloride, must add up to 0. And the reason for that is because that makes the compound stable. If the compound was charged, it wouldn't be stable, it'd be very reactive, and the element probably wouldn't provide the right conditions needed for life for that extra stability that we need. So the charge in all compounds must add up to 0, and that means we need the positive charge to cancel out and equal the negative charge. Well, in this case, I've got +1, and here I've got -1. And I know +1 minus 1 adds up to 0. So I know I need 1 sodium ion for every 1 chloride ion, so the formula would just be NaCl. Moving on to a different example of calcium chloride. I know calcium is in group 2, so it has 2 electrons in the outer shell. It will lose 2 electrons to gain a full outer shell, and therefore calcium forms an ion with a +2 charge. Chlorine we've just dealt with in example 1. It's got 7 in the outer shell, gains 1 to get a full outer shell, so forms an ion with a -1 charge. This time, I need the calcium chloride to add up to 0 to make sure it's stable. So I'm going to realise I'm going to add up +2 minus 1. Now, if you're not comfortable working with negative numbers, try putting it in your calculator. So put +2, take away 1. That's clearly not going to give me 0, so I'm going to have to manipulate the numbers a little bit. I need this +2 to be balanced out and cancelled by this. So therefore, I'm going to need 2 lots of the chloride ion. And only 2 lots of chloride is going to be enough to balance out the calcium. So my formula would be CaCl2. 2 plus from calcium, 1 minus from chloride, but there are 2 of them, so it's 2 minus in total. 2 plus, 2 minus, that equals 0. This CaCl would be very unstable because it would have an overall positive charge and it would be unbalanced. Okay, so it needs to be CaCl2. Now I just want to reiterate what the chemical formula tells us to address some misconceptions that will arise later on in the topic. So what this is actually telling you is the ratio of ions in an ionic compound. So you're only asked to build chemical formulae for ionic compounds, aka between a metal and a non-metal. So that tells you that for every sodium ion, you need 1 chloride ion. It is not telling you that the molecule is just NaCl. So for example, if I ask students to draw NaCl, they often would draw something that looks like this. Okay, that is not the case, and this is a really common misconception. There is not just 1 sodium and 1 chloride ion in a molecule of sodium chloride. This formula just tells me the ratio, aka for every 1 sodium there is 1 chloride ion. What I've drawn on the slide is actually more of a molecule, and that applies to covalent compounds. Ionic compounds form giant lattices, so that means in reality there will be hundreds of sodium ions and hundreds of chloride ions all surrounding each other. So it's not just 1 to 1, so we wouldn't draw it like that, and in a couple of lessons I'll go through the structure of ionic compounds, but I just want to address it now so we understand what this formula is telling us. It's actually the ratio of ions in a compound, not the number of them. So there's not one sodium and one chloride, it's a ratio of 1 to 1. Likewise, with calcium chloride, that's a ratio of 1 to 2. So that means for every 1 calcium found in this compound, it'll be surrounded by 2 chlorides. So it's 1 to 2. Let's go through some trickier examples then. So sodium oxide, I know sodium is in group 1, so it's got 1 electron in the outer shell, so therefore it forms an ion with a +1 charge, Na+. Oxygen is in group 6, so it needs 2 electrons to get a full outer shell, so therefore it's going to form an ion with a -2 charge, O2-. My rule says I need these charges to be equal because I need them to cancel out so the overall compound has a charge of 0. But I know if I put into my calculator +1, -2, that will not give me a charge of 0. I need more sodiums to balance out this -2. In fact, I'm going to need 2 sodiums. So the formula would be Na2O. Because I've got 2 lots of +1 ions, so +2 in total. 1 -2 ion, so I've got +2, -2, and that gives me a charge of 0. Looking at aluminium fluoride, aluminium's in group 3, so there are 3 electrons in the outer shell, so it loses 3 electrons to gain a full outer shell and form a +3 ion. Fluorine is in group 7, so there are 7 electrons in the outer shell, so it gains an electron to get a full outer shell, so fluoride forms a -1 charge. I know if I put into my calculator +3, -1, that does not add up to 0, so this time I'm going to need more of the fluoride ion to cancel out this positive aluminium. And in fact, I'm going to need 3 lots of fluoride to give me a charge of 0, because I've got +3, -1, but if I times -1 by 3 fluorides, that gives me -3. So the formula would be AlF3. Got a couple of more examples to run through, these ones including brackets, and then we'll go through an alternative method that you can use to help you in the exam and speed up the process a little bit. So, calcium is in group 2, so it forms an ion with a +2 charge. Nitrate was one of my special compound ions from the yellow box that you cannot predict, you're going to have to learn, and if you go back to the previous slides, I said it was NO3 1-. +2, -1 does not add up to 0. I need more of the nitrate to cancel out this positive charge. And in fact, I'm going to need 2 lots of the nitrate ion. Now, it's really important that we put this in properly in the exam and format it properly, because you need to show the examiner that you need 2 lots of nitrogen and 2 lots of oxygen. So if you just put a little 2 here, well, for a start, that would read as NO3-2, which wouldn't be correct. So you're going to need to include brackets to show you need 2 lots of the whole compound, both 2 nitrogens and 2 times 3, so 6 oxygens. So the formula would be calcium nitrate. We've included brackets around the nitrate to show we need 2 nitrates. So it times everything inside by 2. Magnesium nitrate will be similar. Magnesium's in group 2, so forms an ion with a +2 charge, and nitrate has an NO3 1- charge. I clearly need more of the nitrate ion to balance out the magnesium ion, and in fact I would need 2 nitrates to make this -2 to cancel out the +2. So I need 2 lots of nitrate, but because I need 2 lots of the whole thing, I've got to use brackets again. So whenever you need 2 lots of a compound ion, you're going to have to use brackets to show the overall compound is what we are doubling. So the formula will be Mg brackets nitrate close brackets 2, and that shows you need 2 lots of the N, and we've got to double the O3 as well. So That's one method of determining ionic formula in the exam, and there's lots of practice you can do in this lesson to make sure you're comfortable with that. And the point of that method is so that you are familiar with and understand the chemistry behind making sure the charge is balanced so that the compound has a charge of 0 to make it really stable. However, there is an easier method to use in the exam, which I'll teach you to save time and speed up the process. But it's really important that you see both so you can see the reasoning and the justification behind the first method. This method is essentially called swap the charge. So you've got sodium oxide and you've figured out sodium's 1 plus, oxide is 2 minus. All you have to do is swap those two numbers. So sodium is 1 plus, so that means you need 1 oxygen. So whatever that number is there, that's what the other ion is multiplied by. So it's 1 plus, so I times oxygen by 1. Oxygen is 2 minus, so I take that number and that's what I times sodium by. So 2 minus, so I need 2 sodium. So all I've done each time is swap the numbers. So that means it's Na2O. And that's how I figured it out much faster, but it's still using the same principles as before. So calcium we figured out is 2 plus, chloride is 1 minus. If calcium's 2 plus, I'm going to take that 2 and I'm going to times it by the chlorine. So I'm going to need 2 lots of the chloride ion. Chloride is minus 1, so I take that 1 and times it by calcium. So calcium, I just need 1 of. So the overall formula would be CaCl2. Nice and easy. Aluminium oxide is a more difficult example, and this is where this method comes in much more useful. So we figured out aluminium is plus 3. So I take that 3 and I times it by the oxygen. So I'm going to need 3 lots of oxygen. Oxide is minus 2, so I take that 2 and times it by aluminium. So I need 2 lots of aluminium. Therefore, my formula of aluminium oxide will be Al2O3. Pause the slides and have a go at writing formula for the following ionic compounds. Okay, so starting with the ones in green, I know potassium is in group 1, so it's got 1 electron in the outer shell. That means it'll lose 1 electron to form a plus 1 ion. So potassium is plus 1. Iodine is group 7, so it has 7 electrons in the outer shell. It gains 1 to get a full outer shell, so iodide forms a minus 1. Therefore, the formula of potassium iodide, I only need 1 potassium for every 1 iodide, so it'll just be Ki. For sodium oxide, sodium's in group 1, so forms a plus 1 ion. Oxygen's in group 6, so it gains 2 electrons to get a full shell, so forms a minus 2. Well, if I swap the charge, that means I'm going to need 1 oxygen and 2 sodiums. Therefore, it would be Na2O. Aluminium is in group 3, so it's got 3 in the outer shell, so it's going to lose 3 electrons to form a plus 3 charge. Chloride's in group 7, gains 1 electron to get a full shell, so it's minus 1. If I swap them numbers, I'm going to need 3 chlorides and I'm going to need 1 aluminium. Hence, the formula is AlCl3. Looking at sodium sulfate, sodium is in group 1, so forms a plus 1 charge. And sulfate is one of my compounds ions you had to learn from the yellow box, and that was SO4 2 minus, so it has a -2 charge. Swapping the numbers, I need 1 sulfate and I need 2 sodiums, so it's Na2SO4. Magnesium is in group 2, so forms a +2 ion. Hydroxide was one of my special compound ions I had to learn, and on the yellow box that was OH1 minus, so it's got a -1 charge. Swapping the numbers, I need 2 lots of hydroxide and 1 lot of magnesium, so it's Mg, and because I need 2 lots of the O and the H, I've got to use brackets, so it's 2 OHs. Calcium nitrate, well, calcium is in group 2, so forms an ion with a +2 charge. Nitrate is one of my special compound ions from the yellow box, and that has a formula of NO3 1 minus, so forms a -1. We need to swap the numbers, so I need 2 lots of the nitrate ion and 1 calcium. And here you can see I've got 1 calcium, 2 lots of nitrate, but because I need 2 lots of the overall compound, I've used my brackets and a little 2 outside the brackets to show I'm timesing the N by 2, and I'm also doubling the O3. Aluminium oxide was on the last page, but I'll go through it again. Aluminium's in group 3, so forms a +3 ion. Oxygen's in group 6, so forms a -2 ion. Swapping the numbers, I need 3 oxygens and I need 2 aluminiums. That's why it's Al2O3. Aluminium sulfate, well, we've just said aluminium has a charge of +3. And we also said sulfate is one of our special compound ions we have to learn. And in the yellow box, it's SO4 2 minus, so it's got a -2 charge. Swap the numbers. I need 3 lots of the sulfate compound and 2 lots of aluminium, so hence it's Al2, and I need 3 sulfate. Because I need 3 lots of the overall compound, I use brackets to show that. Last one, we've got potassium selenide. Well, potassium's in group 1, so forms a +1 charge, and the selenide is the negative ion of selenium, which is in group 6, so forms a -2 charge. Swapping those numbers, I need 1 selenium and 2 potassiums. Hence, the formula is K2Se. So, you should now be able to build chemical formula as well as understanding how it tells us how many of each type of atom there are in a compound. So you do need to go away and practice these, because these come in really, really handy when we're balancing equations. So you can either do your own research and try test yourself with some examples. So use the periodic table to think of some compounds and try and build in the formula, or ask your teacher to give you some examples and do some further practice in your workbook.